to work on number 1 as an example together so that you guys can work through the rest of this worksheet on your own. Also, if you didn't read in the PowerPoint, I wanted to point out that we do have a quiz coming up on Wednesday. It's not over this, it's over the homework that you guys had last time, so be sure that you're studying that. And then your test will be October 20th. So we're going to start with number 1. These worksheets are class sets. Please write this in your notebook. These problems are similar to the problems that we've been doing, but they have unique things that we're going to keep in mind. So instead of being horizontal projectile motion, we're now working with angled projectile motion. You'll know that it's an angled problem whenever you see some sort of an angle in the problem. We're going to work with this motorcycle. A motorcycle runs up a ramp at 30 meters per second. The ramp is inclined at 25 degrees. What are the vertical and horizontal velocities of the bike as it leaves the ramp? And how far away should the landing ramp be placed? So first of all, whenever you have a velocity at an angle, we need to break that down into horizontal and vertical components. So our first step will be to do that. Then we'll come back and we'll find how far away the landing ramp should be placed. So in this case, we're going to be combining our trigonometry that we worked with at the beginning of the unit with the kinematics calculations that we've been doing with horizontal projectiles. So our first step is the same. You'll want to draw a picture of the situation itself. So we're going to draw the motorcycle, and I'm actually just going to draw the path of the motorcycle. This motorcycle jump, they're going to be jumping from one ramp and landing onto another ramp. So we're going to go ahead and label on our drawing what was given in the problem. So given in the problem, we know that the motorcycle runs up at 30 meters per second. So our velocity initially is 30 meters per second. And we know that the ramp is inclined at 25 degrees. So we're given an angle, and the angle is the incline of the ramp right here. So this is 25 degrees. The first thing we're trying to find the vertical and horizontal velocities of the bike. So what you'll do at this point, this is your first step for every problem, you're going to find, this is an angled velocity. You want to find the vertical and horizontal components of that so that we can place it into our equations. So you're going to make a triangle out of this, this right here. So I want you to draw a separate triangle below your drawing. It's going to be a right triangle. This is your horizontal component, your vertical component, and then the angle represents the angled velocity that was given in the problem. So whenever we say 30 meters per second, the motorcycle rider was driving at an angle, and so that means that our hypotenuse is going to be 30 meters per second. We know the angle of the ramp was 25 degrees. And then this is our right angle here. So between horizontal and vertical would be a right angle. This leg of this triangle is going to represent our horizontal velocity, so v sub x. That's something we're trying to find. And then the vertical leg, v sub y, is also something we want to find. So at this point, we have a trig problem. We have an angle and a hypotenuse. We want to find our adjacent leg and our opposite leg. So we're going to use SOHCAHTOA. Let's find x first. Since x is touching our angle, it is the adjacent leg. So we're going to use cosine because we're looking for the adjacent leg and we have the hypotenuse. So our formula for cosine is cosine theta equals adjacent divided by hypotenuse. We can plug 25 in for theta, so cosine of 25 equals our adjacent leg is this x I'm just going to call it x for simplicity, divided by our hypotenuse was 30. To solve for x, you'd multiply both sides by 30. These two cancel out, and you get 30 times the cosine of 25 is going to give us our x velocity. At this point, you'll need your calculator. And you can just plug in 30 times cosine of 25. And you should get 27.2. So our Vx, or x velocity, is going to be 27.2 meters per second. We're going to use the same process to find this Vy. We have the opposite leg and the hypotenuse, so we're going to use sine in this case. So then sine theta equals opposite over hypotenuse. Okay, we can plug in 30 times the sine of 25. And we should get 12.7. So your y velocity is 12.7 meters per second. Now our problem asks for horizontal component of velocity, which is here, and vertical component of velocity, which is here. So those are your first two answers for this problem. The next thing we want to define in part B of the problem, how far away should the landing ramp be placed? So we want to find between the jumping ramp and the landing ramp, what is this displacement? And since this is in the x direction, it's going to be dx. So dx equals question mark. We want to find from here all the way over to here. This is when we go back and we use our kinematic calculations. So this is going to be similar to solving for horizontal projectile motion problems. And our next step would be to make our XY table. Make that up here. We'll still use initial velocity. The light turned off there. Okay. Displacement, acceleration, and time. Okay, in this case, we used to have 0 as our initial y velocity. Since we are launching at an angle, we do have some upward velocity. And that's actually what we solved for over here. So your answers for Vx and Vy are going to go in for your x and y velocity. So Vx is going to be 27.2. Vy is 12.7. Displacement in the x direction is what we're trying to find. That's going to be a question mark, and since it's what I want to find, then I'm putting a box around it. And displacement in the y is something that we can figure out conceptually. So whenever we're talking about displacement in the y, we want to know the difference in position, but only in the y direction between the start of our jump and the end of our jump. So if you start on the ground and you go up, then your y displacement is positive. And then whenever you're coming down, your y displacement is negative. Whenever you get all the way back to the ground, you've gone up and then you come down, your y displacement is 0. Okay, so since we didn't start any higher or lower than where we ended, we have a 0 y displacement. Acceleration is the same as it was in horizontal projectiles, so there's no acceleration in the A. Acceleration in the y is negative 9.8. Time, we don't know, so I'm going to put a question mark there. Again, whenever you find time for one dimension, you found it for the other. So this is the one where once we find one of these, we can just copy it over to the other column. So looking at our two columns, in the x column we have 2 unknowns, so we can't solve yet. In the y column we only have 1 unknown, so we can solve for time here. Trying to find displacement, so once we find time, we'll put it over here and then we'll solve for displacement in the x direction. So just like horizontal projectiles, we'll be using the same equation for y. So our equation is your displacement formula, d equals vi t plus 1/2 a t squared. We're going to plug in our numbers from up here. So displacement in this case is 0. 0 is equal to 12.7 times t plus 1/2 of negative 9.8 t squared. All right, we've got two variables, but that's okay. We're going to take care of it. It won't be as bad as you think it is. So the 12.7 is multiplied by the t. We're going to keep those together for now. Then we've got a plus sign. Plus sign separates this half of the equation over here. This stuff is all multiplying, so it's going to stay together. So what we can do, since we have a 0 over here, we're just going to subtract one of these and move it to the other side of the equal sign, and then we'll have an equality. What I'd like to do is take the second half of the equation and subtract it over to the left side. So we're going to do minus 1/2 times negative 9.8 t squared on both sides. On the right side, this whole thing cancels this whole thing out. On the left side, we just end up with negative 1/2 times negative 9.8 t squared equals 12.7 t. Okay, just to make this a little bit easier, let's go ahead and combine these. So since these are both negative numbers, they would combine to make a positive number. 1/2 of 9.8 is 4.9, so we get a positive 4.9 t squared equals 12.7 t. Now we can do something to get rid of to get rid of one of these t's to make our problem easier to solve or possible to solve. So since there's a t squared and a t, we have a common denominator of t, so we can reduce by dividing a t out. So let's divide t on both sides of the problem. These two cancel out. This guy cancels out with one of these. So the square goes away, but we keep the t on the left. So you end up with 4.9 t equals 12.7, and from here it's cake. We divide both sides by 4.9 to get t by itself, so we're going to do 12.7 divided by 4.9. You'll get let's round that to 2.6, so t equals 2.6, and since it's a time, it is in seconds. Okay, now that's not what we were asked for. We wanted to find displacement, but this is the first step to finding that. So back up here with our XY chart, I'm going to put 2.6 in on both sides. Now we have two variables in the x column. We can solve for displacement using our velocity formula. So back down here, we're going to do v equals d divided by t. Plug in velocity, which was 27.2, equals displacement is what we're trying to find, divided by our time, which was 2.6. To get d by itself, we're going to multiply 2.6 on both sides. These two cancel out. 2.6 times 27.2 is going to give us 70.5. And that's a displacement. So we had to move the ending ramp 70.5 meters away. And that's our answer, so we will put a box around it. Okay, so these are kind of lengthy, but they're not all that difficult. It's the same stuff we've been doing. So I need you guys to follow this process. This paper will be on my desk over here, so if you want to come look at it and look at the math that I went through, you're welcome to come look at this. And then as you're finishing the problems on the projectile worksheet, I just wanted to mention that number 3 is special. So number 3, it says that you'd like to find the maximum range of a cannon that fires cannonballs at 500 meters per second. So you're given a velocity, but you're not given an angle. So in this case, the angle is 45 degrees. And if you are a sports fan or if you play Angry Birds, then you should know that 45 degrees is the angle that will provide you the longest range. Range just being the horizontal distance. So anything shot at 45 degrees will go the farthest in the x direction. Complete these during class today. Anything that isn't completed during class today will be homework, but since they're class sets, then please take a photo of this paper or look on my website to find a copy of this. I'll check these on Wednesday, and you guys have a quiz on Wednesday. So have a great weekend, and I'll see you guys next week.